Now I try to explain you and go over all the different parts of wave, which is anatomy of waves. I will do it in two cases for transverse wave and a longitudinal wave. Let's start with transverse wave. So transverse wave, just for quick review, it's a wave where the direction of the wave is this from left to right, and the force that is applied to make the wave, it's perpendicular to the direction of the wave. So if the direction of the wave is this direction, this way, the force to create this wave, it's perpendicular, which means it's 90 degrees to the direction of the wave, and we are moving hand up and down right here to create this wave right here. The very first part of anatomy of wave, it's equilibrium. It's not a part of the wave, but it's pretty much the place when the wave and the particles of the waves are in equilibrium, in a rest position right here. Okay, so if you imagine that this is a rope that's being moved up and down that creates this wave. If the rope will be in the rest position, it will be lined up along this line right here, and we call this equilibrium. The next part of the wave is the crest. Crest are the points right here on the very top of the wave. And opposite to crest, we have throat, and those are points. Throat are points on the bottom of the wave. So it's the most displaced part of the wave below the equilibrium. Next things what we're going to talk about, it's amplitude. Amplitude is the place between equilibrium and the crest, the highest point of the wave. So we will have amplitude in here, right here, and right here. So every single time you're going to be asked what is the amplitude of the wave, you're going to measure the distance between the equilibrium and the crest. The very last things, it's a wavelength. So a wavelength is pretty much the whole cycle of the wave, so the whole wave. The whole wave will be from crest to crest, okay? So the whole piece right here, it's a one wavelength. The other wavelength will be from this crest to this crest, and this whole piece will be another wavelength. The same is, we can also find a wavelength from throat to throat. So either the highest point to the highest point, or the lowest point to the lowest point will be the whole wavelength. So that's pretty much all the parts of a transverse wave. We're gonna move on to longitudinal wave. So longitudinal wave has those little pieces right here that are a little bit more contract, and pieces that are a little more spread apart right here, okay, and in between. Longitudinal wave, it is wave where the applied force to create this wave is parallel to the direction of the wave. So if the wave is moving this direction, the applied force must be in the same direction as the movement. So the place when we see the wave kind of like tied together, when the density of the wave is really high, we call this compression. And the places when the wave it's spread apart right here and right here will occur refraction. So now we need to find the amplitude of the wave, and it's pretty much the same things like for transverse wave. We can actually see right here is equilibrium of the wave in the middle of it, and the amplitude will be pretty much the same things. It's the distance between the equilibrium and the highest point of the wave. So it could be right here or right here, anywhere between the equilibrium and the very top. And very last part of this longitudinal wave, it's a wavelength. So in longitudinal wave, the wavelength we will measure from the compression part to the next of compression part. Okay, pretty easy. That's the whole wavelength. So that will be the end of it. Please watch this video, take your notes, ask questions if you have any questions, if you want me to clarify something for you or repeat it for you. Okay, hopefully this helped you out to understand everything what you were doing so far, and let's move on.